Here's a GRE coordinate geometry question. Let's take a look. A point located at the origin of an XY coordinate plane can travel a maximum straight line distance of 3 units. Which of the following XY coordinates can the point reach? And we're going to select all that apply. And before we dive in, just a reminder that my name is Andrew and I solve GRE questions. All right, let's get into it here. So we're dealing with an XY coordinate problem. And the first order of business, in my opinion, is to draw an XY coordinate plane. It just helps to visualize it. And what we're told is that we have a point located at the origin. That's the point 0, 0, right? Dead center of that. And it's allowed to travel a straight line distance of 3. So it could go 3 up. That's the point 0, 3. It could go 3 over. That's 3, 0. It could go 3 down. That's 0, negative 3. Or it could go over. Negative 3, 0. In essence, I'm going to draw this. It's bounded by a circle, right? But what we want to figure out is which one of these points can it reach? So it can reach anything in this circle, including the very edge. Well, first things first, it can definitely reach the point 3, 0, right? 3, 0 is right there. So that's good. How about the point 2, 3? Well, the way to figure out a straight line distance in a coordinate plane is actually with the Pythagorean theorem. You thought I was going to say distance formula, right? And here's the thing, and I don't want to get too much into this. The Pythagorean theorem is the distance formula, and the distance formula is the Pythagorean theorem. If you want to see why, maybe comment on this video, and I can do a follow-up. Okay, so let's take the point 2, 3. I don't know exactly where that is. Let's just say it's somewhere around there. I don't know if it's in or not. Right? The point 2, 3. Well, what's the straight line distance from 0, 0 to the point 2, 3? It's going to be the hypotenuse of a right triangle. Everybody see that? Right? So that there is the point 2, 3. If I'm starting at 0, 0, I go over 2 and up 3. That means the hypotenuse, if that distance is 2 and that distance is 3, is going to be the square root of 4 plus 9, or the square root of 13. But the square root of 13, I found this hypotenuse. And you know what I'll do? I'll draw this out even bigger just so everybody can see it, right? That's a distance of 2. That's a distance of 3. So a squared plus b squared, 4 plus 9 is 13. So that's going to be the square root of 13. That is bigger than the number 3, right? Because 3 is the square root of 9. So that one's out. And I can do this for all of them. So for example, here, if I take the point 1.5, 1.5, that's going to be 1.5 squared plus 1.5 squared. So 2.25 plus 2.25, and that's 4.5. Take the square root of that, definitely smaller, so it's in, right? How about the point 1, 3? Well, 9 plus 1, 3 squared plus 1 squared, is 10. Take the square root of that, bigger than 3. So it's outside of the range, right? I'm only allowed to travel a distance of 3. How about this one? 1 squared plus 3 squared, right? That's, oh, sorry, I just did that one. How about E? That's 1 squared plus 2.25 squared. When I did this on my calculator, I got this to be the square root of 6.0625. So that is in. It's smaller, right? How about this one? This just misses it. I think this comes out to the square root of 9.0625. That's out, right? Not included. And then this one comes to 2.5 squared. What's that? 6.25 plus 1.5 squared. That's 2.25. It just makes the cut. It's just underneath, right? Because it's just under 9, 8.5, I believe. Square root of that. Correct answers here, A, C, E, and G.